Hello everyone. Here we are in the topic odd man out, and which is the part of quants aptitude. So today we are going to deal with this topic which is almost similar to number series topic which we already have discussed. So in this exactly how the problems are. So let's consider one example. So in this, if we have this series like 2, comma 4, comma 6, comma 7, comma 10, comma 12, comma 14. Let's say we have given this series, we have to find out the odd term out of all these terms. So we have 2, 4, 6, 7, 10, 12, 14. Obviously, since this is very simple, we can easily say that the difference is of 2 or it is the even series. So the seventh, this term, the number 7 is the odd term. So this is how these problems will be based on finding out the odd terms inside the series. So in case of number series, if it is the problem of number series, maybe this term is already given 8 and we have to find out the last term of that series, which can be the example of number series. But in case of odd man out, we don't have to find out the next term, but in that series itself, one of the term will be given in a wrong way, maybe 7, 9 or any other number, and we have to identify which one is the wrong term out of that series, which is the odd term. Okay. Now, talking about types of the odd man out series, there could be number series, there could be letter series, or combination. In case of number, we may have 2, 4, 6, 8, and so on. In case of letters, we may have A, B, C, D, and kind of series. In case of combination, it may be A1, it may be B2, C3, D4, and so on. Combination of letters and numbers. Now, main part is strategy, how you can deal with this topic. So basically, if we talk about the comparison part, if we compare the odd man out topic with number series topic, the odd man out topic is slightly difficult than number series. The thing is, in case of number series, the series is already given and we have to find out the next number. So we know the logic, perfect logic we can find out, and then next number we can easily think about it, find out the next number. But in case of odd man out, even though the series is given, but any term out of that series could be wrong. It could be odd term, and that's why we have to identify the pattern, identify that wrong term, and then we are able to get the answer. But in case of number series, the perfect logic is already given, series is already given, and we just have to find out the next term out of it. So number series problems are slightly easy to solve. Instead of simple, we can say these are easy to solve, and these are slightly difficult to solve. Odd man out series. So more practice can be expected in this topic. And talking about strategy, how we can deal with it, the strategy could be same as number series topic. So in number series topic, if you remember, we had a strategy in that first we have to check that number series numbers, those are given over there. We have to check whether they are prime numbers or not. If no, then check for the differences between the terms. Then if that logic is also not working, then we can go for squares, cubes, square roots, cube roots. If that is also not working, then we can go for multiplication, division kind of logic. If that is also not working, then we can go for the combination of above logics. This is how we had seen the strategy in case of number series. Same kind of strategy we can apply here in case of odd man out topic. In addition to that, we have to identify the pattern first by using the strategy that we have already seen, just I said. And after identifying that pattern, find out the odd term of that series. Find out the odd term of that series. This is how we can deal with this topic, odd man out. Now let's go through few problems so that you will have a better confidence while dealing with this topic, odd man out. Now let's go through few examples. So here we have taken few different types like squares, cubes, odd numbers, even numbers, multiplications, and prime numbers. Okay, let's deal with examples of each. In case of squares, let's say if we have the series like this 1, comma 4, comma 16, comma 24, comma 49, comma 64. Let's say we have this series. Now in this series, if you note down, 1 is actually a square of 1, 4 is square of 2, 16 is square of 4, 24 is not a square of any term, any number, 49 is a square of 7, and 64 is a square of 8. So in this series, 24 is not a square of any number. That's why we can say that this is the answer. This is the answer. Odd term is 24. Similarly, in case of cubes, we can say that let's say if we have 1, then 8, then let's say 27, then 64, let's say 124, and so on. Okay, let's say we have this much series. Now in this case, what happens is 1 is a cube of 1 itself, 8 is a cube of 2, 27 is a cube of 3, and 64 is a cube of 4, and 124 is not actually any cube. If it is 125 instead of 124, if it is 125, then it would have been cube of 5, but since it is 124, so in this case odd term is 124, and that we can put as the answer. Okay. In case of odd and even numbers, it's very easy. 2, 4, 6, 8, let's say 9, then 12, 14, 16, and so on. So all these terms are even numbers. These are 2, 4, 6, 8, except 9. So 9 could be the answer. Similarly, in case of odd numbers, we can have 3, 5, 7, 8, 9, or instead of 9 we can take 11, 13, 15, and so on. So in this series, here we have all the odd terms except 8, which is the answer, right? In case of multiplication, we can have the examples like, let's say 2, 4, 8, 16, 32, 60, and so on. Okay, maybe next term we can take as 128, for example. So here, what is happening? If you concentrate on the series 2, 4, 8, 16, we are doubling the number each time. Double of 2 is 4, double of 4 is 8, double of 8 is 16, 32. Double of 32 is actually 64. But here we have 60, which is the odd term. Double of 64 is 128, which is right term. And this is the odd term. This should be the answer of this series. So that could be multiplication type of example. In case of multiplication, we can take one more example as like this 22, then 66, 99, then 121, comma 279, comma 594. Now in this, what happens is all the terms, if you closely review, all the terms are multiples of 11. So 11 twos are 22, 11 six are 66, 11 nines are 99, and here also 121 is 11 into 11 is 121, square of 11 is 121. Now in this case we need to check 279, and in this check also we need to, in this case also we need to check. So if we refer our shortcut tricks divisibility test that we already have in one of the video, in that case if we check the odd terms and even terms, addition of both, 5 plus 4 is 9, 9 minus 9, addition of odd terms is 5 plus 4, and even term is 9. So 9 minus 9 is 0, and that's why this number is perfectly divisible by 11. That's why this is multiple of 11. In this case, it is 9 plus 2, it is 11. 11 minus 7 is 4. So 4 is not divisible by 11. That's why this term is also not divisible by 11, and that's why this should be the odd term. 279 should be the odd term. So this is how simple examples. Now what we will do, we will go through few more difficult examples, difficult questions, so that you will build better confidence while solving this odd man out topic. So here we have three more examples of a little difficulty level. Maybe we can say medium difficulty level. So let's go through one by one. So first example given here on the board is 1, 2, 6, 15, 31, 56, 91. So as per our strategy of number series topic, these first step is identifying the prime numbers. These are not the prime numbers, all of them. So prime number logic cannot be the case here. Let's go for differences, finding out differences. So if we find out the differences, here the difference is 1, here the difference is 4, here the difference is how much? 5 plus 4, 9. Here the difference is 15 and 31, so 16 is the difference. Here how much is the difference? So if we make a double of 31, it is 62, and 56 is there, so 6 less for 31, which is 25. So difference is 25. And here if we find out the difference, 56 plus 4 is 60, and 60 plus 30 is 90, and 1. So 30 plus 1, 31, plus 4, 35. Difference is 35. Okay, so here when we look at the differences, we will see, or we will identify a logic. So all these are squares of some number. So for example, this is square of 1, this is square of 2, square of 3, square of 4, square of 5, and this is not a square of any number. Instead of this, if it would have been 36, then it is a square of 6. But since the difference is 35, so what we can say that since this difference is perfect, so 56 is perfect, this difference is wrong, so there is a problem with either this or this. Okay, so since this is perfect, so this number and this number both are perfect, and in this case, then this should be the culprit, we can say, or the odd one out. So this is our answer. 91 is the odd one out number. Okay. Let's go for second. Now in this case, we have 190, 166, 145, 128, 112, 100 and 91. So here, if you observe, we are decreasing the numbers. So the numbers are, series is not increasing, it is decreasing kind of series. So maybe difference logic should be applicable over here. So if we find out 190 and 166, what could be the difference? So 166, if we start counting from this, 166 plus 4 is 170, 170 plus 20 is 190, so difference is 24. If we see the difference here, 166 and 145, 145 plus 5 is 150, 150 plus 10 is 160, and 6 more to it. So 10 plus 5 plus 6, that goes to 21. Here the difference, let's find out 128 and 145. So 128 plus 2 is 130. So 130 plus 10 is 140 and 5. So 10 plus 5 plus 2. The difference is 17 over here. If we see the difference here, 112 and 128 we have. So 8, if we add in this 8, then it is 112 plus 8 is 120. 120 plus 8 is 128. So 8 plus 8, 16 is the difference. 112 and 100, the difference is very easy, 12, difference of 12, and here it is a difference of 9, very easy to calculate. Now when we observe the differences, if we are able to get some pattern out of it, some logic out of it, then this will be solved very easily. So when we look at it, 24, 21, 17, 16, 12 and 9. So there is some pattern between 24, 21 as well as 12 and 9. The pattern is, it is in the multiples of 3. Okay, so if this is 9, 12, then this should be 15. Instead of 16, this should be 15. After 15, next multiple is 18. Instead of 17, this should be 18. Then 21 and then 24. Right? Now, both these terms are different. So maybe the problem is with this, this or this. And since both these differences are incorrect, so maybe if we change this number 128 number, we may get some solution out of it. So instead of 17, this should be 18. So we need to increase here, we need to decrease this. Actually we can increase this or decrease this. So we can decrease this, it should be then 127 instead of 128. And here the difference is 16, that should have been 15. So in that case also we need to decrease this or increase this, right? So if 127 is taken, then let's check out the difference. 145 and 127, the difference is 18. 127 and 112, the difference is 15, and logic is perfect. Okay, so that way 128 is the answer, wrong number, odd man number, and instead of 128, 127 should be there to make the series perfect. Okay, let's go for next example. 80, 119, 166, 221, and 283. Okay, now in this series, again if you check, it is increasing by some difference. So let's take out the difference again here. So 80 and 119, what is the difference? 20 plus 19, the difference is 39. Here, what could be the difference? 119 plus 1 is 120, and then 120 plus 40 is 60, and one more 6. So maybe the difference is 47 if I make it like this. Here, what could be the difference? 166 and 221, the difference is 4. If we add 4 in this, it becomes 170. 170 plus 20 is 50. 170 plus 50 is 220. So 50 plus 4 and this 1. So together 55 should be the difference. And here 221 and 283. So what could be the difference? We can say 60 and 2. 62 should be the difference. Are we able to find out any logic in these differences? 39, 47, 55, 62. Again, these numbers are increasing by some common difference. That could be the remark over here. Observation could be here. So let's again take out the difference of difference. So 39 and 47, difference is 8. 47 and 55, difference is again 8. 55 and 62, the difference is here 7, right? So if this difference is 8, then we can say that the logic is perfect. So to make the difference over here, since this is perfect, so both these numbers are perfect, but this is wrong, so there must be something wrong with this or this. But according to this logic, this number is perfect, so we have to deal with this. So to make it 8 over here, we can make this 63. So I will mention that 62 as it is, and we'll circle it, we'll make it 63. To make this 63, we can again add one more here, and that could be 284. So there is something wrong with this number, and if it is 284, the difference will be 63, and this difference will be then 8 instead of 7. This is wrong. So as per this logic, this is the odd one out, right? 283 is odd one out, and that should be the answer. One more logic we can apply, and that could be, if you again observe the numbers, these numbers 80, 119, 166, 221, and 283, all these numbers are near to some squares. For example, this 80 is this square of 9, maybe minus 1. So 9 square is 81, 81 minus 1 is 80, right? Then here 119 we have, so that could be square of 11 minus 2. Square of 11 is 121, minus 2 becomes 119. Then 166 could be the square of 13 minus 3. Square of 13 is 169, minus 3 gives 166. So this logic is also getting perfect. Let's check for the next number. Next we have 221, and square of 15 is 225. 225 minus 4, that gives 221. So this is also perfect. And next should be, so if you check out the series, 9 square minus 1, 11 square minus 2, 13 square minus 3, 15 square minus 4. Next should be 17 square minus 5. So 17 square is 289. 289 minus 5 should give 284. So by this logic also, this term is odd. This term is odd, and that should be the answer. So here we have two more problems of high difficulty level. So let's try to solve this. You can pause the video here and try on your own. If you are not able to get the answer, we will together try to solve these problems. So in this problem, high difficulty level first problem, 8, 8.5, 11.5, 14 and 17. These are the terms. Obviously, these are not the prime numbers, so that logic cannot be applicable here. We need to check for differences. Squares, cubes, that also cannot be the logic. Multiplication maybe, but as of now, differences should solve this problem. So let's go for differences. Difference between 8 and 8.5 is the difference of zero point 0.5. Difference between 8.5 and 11.5, that is 9, 10, 11, 3. Difference of 3. 11.5 and 14, the difference is here 12, then 13, 14. So 2.5, and 14 and 17, the difference is 3. Okay. Now, if you look at the differences, here it is 0.5, here it is 3, then the difference is getting decreased. Instead of increasing by some increment, it is getting decreased here, and then again it is increasing. So might be there must be something wrong with this. Okay, there might be something wrong with this. So if it is wrong with this, then this and this number is in focus. So instead of this, if you look at the differences here, zero point 0.5, 3, 2.5 and 3. Okay, so if it is the incremental kind of differences, then 0.5, after zero point 0.5 there should be 1, then 1.5, then 2, 2.5, then 3. That should be the series. But here 2.5 we have, 3 we have, but here 2 is not there, and here again if this is 2, then this should be 1.5. That is also not the case. So there must be wrong with maybe these two numbers. There must be something wrong with these two numbers. So let's check for this. Let's check for this number first, 8.5. So instead of 8.5, let's say if this is our answer, this is the odd term, then what should be there in place of 8.5 to make this logic perfect, to make this series perfect? So let's think about it. If we are right, then only we can say that this is our perfect answer. Okay. Now to maintain the series 3, 2.5, here the difference should be 2 instead of 3. It should be 2. To make it 2, 11.5 minus 2, it should be 9.5, right? And if it is 3, 2.5, 2, then this must be 1.5. Instead of 0.5, it must be 1.5. To make it 1.5, 9.5 minus 1.5, it gives 8. And that is perfect. So the logic is, instead of 8.5, if it is 9.5, the number, then we are getting the difference as 1.5, 2, 2.5 and 3. And that's why 8.5 is the odd one number, odd man out. And instead of 8.5, there should be 9.5. So this way we are cross-checking our logic. We are not only identifying the odd term, we are cross-checking our logic, and that's why we are 100% right that this is the odd term and this should be the number. 9.5 should be the number instead of 8.5. Okay. Now let's go for the second difficult problem. I hope you might have tried this. If not, try for this and then go for the remaining part of the video wherein we will try to solve this. Okay. So as usual, check for prime numbers. Obviously, these are not the prime numbers. Differences we can check, but instead of differences, if you look at the numbers, these are increasing by huge differences. So here you can see 17, 20, 46. Up to this, it's okay. But after that, 147, there is a considerable difference, we can say. After 147, it's 599, almost 600. After 599, we have 3000, and after 3000, we have 18,000. So I don't think so that differences will work here. Instead of that, we should try for multiplication, logic of multiplication. If we are thinking about the multiplication logic, then 17 we have, 20 we have, 46, 147 and so on. Now if we look at these last two terms, 3000 is there and 18,000 is there. If multiplication is the factor, then 3000 into 6. will give 18,000. Okay, 3,000 into 6 will give 18,000. So maybe multiplication of 6 could be here. If we are concentrating this on this, it's almost 600. We can somehow approximate it. So 600 and 3,000. What could be the multiplication? 6 5s are 30. So maybe multiplication of 5, right? So here it should be multiplication of 4. It is almost 150. Sorry, it is almost near to 150. So 150 into 4. 15 fours are 60. So multiplication of 4 and so on. So it should be multiplication of 3. It should be multiplication of 2. Here it should be multiplication of 1. Right. So this way we are able to get some approximate logic. It's not the perfect, but approximate logic we are able to get out of it. Now, if it is 17 into 1, but we need to add something to get 20. If this is the perfect, if it is not odd one out, if it is perfect, how many numbers we can add? So it may be 17 into 1 plus it may be 3. That could be the logic. So instead of this bracket, I will put it here so that it will be clear. 17 into 1 plus 3. Maybe 20 into 2. 20 into 2 is 40. 40 plus 6 is 46. Maybe 46 into 3. 46 into 3 is how much? Let's do that over here. 46 into 3. 6 3s are 18. 1 is the carry. 4 3s are 12. And it is 138. So 138 and 147 we have here. So what is the difference? 147 and 138. The difference is of 9. So we can add here 9 to get this number. So 46 into 3 plus 9 gives this. So this seems to be the some kind of perfect logic. 17 into 1 plus 3. 20 into 2 plus 6. Into 3 plus 9. Into 4 plus 12 should be there. Plus 12 should be there. Then some number into 5 plus 15 should be there. Some number into 6 plus 18 should be there. That should be the logic. Let's check for the remaining numbers. Now we calculated till this. Now let's go for this. 147 into 4 plus 12 is how much? 147. So we will do it here. 147 plus into 4. So 7 4 the. So instead of that, what we can do, we can assume this as 150. So 150 into 4 is 600, and 3 is extra we have taken, so we need to subtract 12 out of this. 600 minus 12 is how much? It is 588, and here again we need to add 12, so that is 600. So instead of 599, it should be 600. As per our calculation, it should be 600. Then 600 into 5, 5 6 are 30, so 3000 is the answer. 3000 plus 15, 3015 is perfect. 600 into 5, 3000. 3000 plus 15 is 3015. So this is perfect. 3015 into 6. Let's do it. We will do it here. 3015 into 6. That we have to do the calculation. Forget about this 15 for some time. 6 into 3 is 18. So that gives the answer as 18,000. 15 6 are 90. So let's add it to get the answer as 18090. So 18090 plus 18 we need to make. Plus 18 we need to make. So let's add 18 into it, and that gives 80181. So exactly after adding this, we are getting this number. So this is perfect. This is perfect. Instead of 599, here 600 should be the number. This is perfect, 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 everything. So this is how we have the perfect logic. And this is the odd one term, odd man out, odd term. 600 should be the term, and this is our answer. So this way we have to solve the problems based on odd man out series. In case of, again I am repeating, if we compare with number series has the perfect logic which is already given, and we just have to find out the next term in case of number series. But in case of odd man out, we don't have to find out the next term, but we have to find out which one is wrong number. We have to identify the wrong number. We have to identify that missing part missing logic part, and that way these problem or this topic becomes a little difficult than number series topic. But if you go step by step and if you practice a lot on this topic, I'm sure you will be able to solve this very easily. So at the end, from my side, the strategy and golden tip for solving these kind of problems will be go with the strategy of number series, that is deal with prime numbers, then differences, check for differences, then go for cubes, squares, square roots, cube roots. If not, then go for multiplication logic. If that also not the case, go for combination. For example, here we tried combination. Go for combination. And in case of odd man out, we have to find out the pattern, and as per that pattern find out the odd term. That should be the strategy, and we can say that golden tip. Okay, so do a lot of practice on this and become perfect, confident on this topic. Thank you.